I'm going to talk about hybrid search today, which we'll define what that is in a little bit. But yeah, I'm Doug. You may know me at any place where internet accounts can be had at Software Doug. You can find me as Software Doug on LinkedIn, on Blue Sky, Twitter/X, the web, World Wide Web, Peloton. Just go find me on Peloton if you want to do rides with me, start a Peloton group. And a lot of people may know my blog or know me from having worked at Open Source Connections or just through the years talking about search in lots of different aspects since the early 2010s. I've been doing some version of search. Ironically, one of the very first search projects I did was a vector search project with John Berryman, where before people really had too much of a name for what an embedding was, we used something called latent semantic indexing to do some matrix factorization of some text to try to see if we could use that to sort of like generate synonyms and that kind of thing. And this was like pre-Word2Vec, pretty old school stuff. Um, we had to use Hadoop and it was a much more painful experience than it would be today. The world has come a long ways. Um, But before we get started, just like obligatory plugs, Hamel has his class, AI evals for engineers. It's a great class for just learning how to actually like approach your application, build it from a systematic way of measurement. And I'm doing a class in July for cheating at search with LLMs, which is kind of like, can we get 80% of the way there without having to think too hard, just with some LLM query and content understanding, taking apart queries with LLMs. I feel like a lot of the search stack is being rethought right now around LLMs when it comes to query and content understanding. Um, Now that it's become it's gradually becoming easier and easier to and cheaper to either host an LLM yourself or to like call OpenAI and all the other providers are having for their have lots of small model options that are increasingly cheap and sort of like pushing down the price over time. So a lot of cool stuff there to play with. So that's all coming. I really encourage you to come and see if my assertions about how far we can cheat at search without having to break out something like PyTorch, how far we can push that. Uh, I'm going to talk about hybrid search, which is the combination of these two search worlds, lexical, which is pure string matching, and vector, which is embeddings, more like statistical similarity of text. What I'm not going to talk about, because I feel like most people probably have a sense for these things, but how something like lexical search actually works. Lexical search is the OG search that has based on thinking about how we tokenize text so that strings match really well with things like stemming or lemmatization. People use synonyms. People build their own crazy semantic search using taxonomies. A long time ago, when people talked about semantic search, they usually meant taxonomies and managed vocabularies. They didn't mean embeddings, maybe 5 or 10 years ago. And of course, that's changed. But all of that's built on string matching. And if you're interested in how all that works, like the core of lexical search and techniques around making lexical search better and getting more out of BM25 kinds of scoring techniques, definitely check out Relevant Search. Also, not going to talk about like what is an embedding. If you know an embedding, I feel like you've probably heard a million times what an embedding is. It's just an array of floating point numbers where when the arrays or vectors, so maybe 256 to 1024 to higher dimensions, when they're close together, that means whatever they're representing, be it a passage of text or an image, are semantically similar. And if they're farther apart, they don't have anything to do with each other. And there's a whole other world and set of books and things that have been written and need to be written about just embeddings in general. But these are the two universes we're talking about. And assuming a little bit you're coming with that information. Because I feel like we've all been inundated with like the vector database folks and everything at this point of like what an embedding is and how to use it. The other thing I won't cover, which a lot of people start with, are like sort of naive strategies of interleaving two search systems. So a traditional thing that comes up if you're starting with an old school search system that's relatively mature and you just want to layer in vector search is to use something called reciprocal rank fusion. I have a blog article called RRF is not enough. But the reason I'm not talking about it, I mean, I think there's a lot of some people, you may get value out of it. It's useful when both both if you're it's basically RRF is a way of combining two completely different systems, two completely different set of search results into a single set of search results. Uh, if you are interested in that, definitely it's not necessarily useless, but it's only useful if vector and lexical search provide results of equal but different quality. If your lexical search is terrible and you're combining it with a pretty good vector search, you're just going to drag down the vector search and vice versa. So it's maybe something to kick the tires of, but I don't think it's that particularly interesting or necessarily where we want to be as an end state. It's kind of a stop off for a lot of teams. Um, and then I'm going to talk about a bunch of assumptions that go into how we think about building a hybrid search ranking function. The other thing I'm not going to do necessarily, which you should do, is systematically go through. I have a blog article that does this, and I really encourage you to check it out. I'm not going to systematically go through and be like, I measured this approach, and the NDCG or some metrics prove that it's good. I have done that, and if you go to my blog and look for like the Elasticsearch hybrid search blog posts, you can check that out, where I have a sandbox of trying a lot of these different techniques to just kick the tires, try different things out, and a lot of the approaches here have proven effective. Um, but I do want to give you an intuition for my assumptions on why building a ranking function like I'm going to talk about is an effective way to do it. So my first assumption is typically embeddings are a good first pass of similarity. So you can see here, I have these two maybe document titles. Mary had a little lamb. Little Red Riding Hood had a baby sheep. And they don't really share, maybe they share a little, but they don't really share important terms that like a lexical similarity would catch. What they do share, you can see the vectors are just eyeballing them. You see they're pretty close to each other. So it's kind of a sense of we are in a general sense without thinking much about what the query is or how we should serve this query. It gives us in the ballpark semantically of what should be their search results. It's sort of like a good first pass set of candidates. So that's my first assumption. My second assumption, this applies especially to RAG folks, but it's not only a RAG thing. In search, it's underappreciated. What is the document in my search engine I'm representing? I'm assuming that you've taken the time to chunk this into something that's a semantically meaningful chunk. A long time ago, I worked on a project for O'Reilly Media that was about one of the incarnations of the Safari online book project. And the biggest thing that improved search was not, and this was pure lexical search, but the biggest thing that improved search was how we subdivided the books into sections in a semantically meaningful way. And so things that were kind of roughly article length in a way that you could peruse through them. Uh, it's really important. So how your similarity systems play with and how you're chunking the content up is really important. And your data may just be naturally represented, like you have a product with a description and an image and these and a name and that kind of thing. But it's an important data modeling thing to think about with search. The other assumption that I think is important when you're doing hybrid search, and this is starting to get to like hybrid search techniques, we often think about an embedding as a thing for a piece of our content. In my mind, and this is not always the case we have, but in my mind, we want to evolve gradually to having as much as possible an embedding for the thing being searched. That's our first pass embedding. We could have like other embeddings. Maybe we do some kind of re-ranking and stuff, but we need a good first pass retrieval embedding that sort of represents the thing being searched. And you can see here as a naive example, making sure I'm getting for this product data set the name and the description in the embedding, but there could be other metadata that we want in there. Um, and the other thing is the embedding is sort of, it's not necessarily, people may know the concept of a two-tower embedding, but at a minimum that the embedding is sort of like two-towerable in a sense that if you give it a query, like a short bit of text, and you give it a document, that they will relate to each other, that they'll be seen as similar, even though the query is relatively short and the document is longer. And that you can put both types of text into the embedding and it'll work. This, if for example, one thing to think about, let's say you have an embedding model, maybe you have an embedding model that's like extremely super targeted to like medical users. Like it's really good at it's like taking apart medical documents and all this stuff. It can really speak that jargon. If you have lay users, like people who don't know medicine coming in to search, is their vocabulary going to map to the document's vocabulary? If you want a really cool thing to search for in the realm of information retrieval, that's like an old problem. It's called a vocabulary mismatch problem. And it's basically like if I hold something up, there's research. If I hold this up and ask people to name it, there's a lot of variety in like people's first word that they will name this thing. Um, People will say mug, some people will say cup, some people will say glass. Some people will know a lot more about like the manufacture of this thing and what it is. And that's something that search is like constantly working against, both when we're developing embeddings and when we're building our using embeddings themselves. And even better, because I talk about embeddings as a great first pass retrieval system, everyone, it's great if we can move to as much as possible, you may have heard like bi-encoder models, all these things, but notionally a two-tower model is specifically a model where we take query features, document features, and to solve that vocabulary problem, we learn the similarity space. Maybe we start with some embeddings in each of these attributes, but we learn the similarity space. Won't get into that here, but that's like a bonus that is something you want to evolve that like first layer of embedding retrieval to get to a good, even better and incrementally get better at this process. So the other thing after we do this embedding, we've retrieved some embeddings. That's really where we want to think about our query understanding and be like, oh, we've got a good set of candidates here. Let me move up things like the query mentions color. Let me move up the color matches. Let me make sure I prioritize the name matches because the users, I understand the user search for something by name, that kind of thing. And I definitely recommend Daniel Tunkenlang's work on query understanding. That's like his whole thing. Query understanding is going to be a big topic at my course, cheat at search with LLMs. I feel like LLMs are basically going to complete this used to be the kind of thing where like to understand if a color was mentioned in a query would be a, months long project or something. Now it's like, hacking it together in a week or something. So ideal is some kind of query understanding, first pass embeddings, and then some later layer of boosting, re-ranking. Re-ranking could be a model. Re-ranking could be manually tuned. All of those are totally valid. Uh, the reality is we can't pull back. If we did this for every result in our index, we would be processing millions and billions of results out of our search engine. We would just see everything ranked in the engine from most similar to least similar. And that's not something that's realistic. The realistic thing is we get maybe 100 embeddings. And out of those 100 embeddings, we have to do that like re-ranking and making sure that we have enough candidates that are like of things like exact name match or color when the user mentions that, it to actually boost them or re-rank them or to treat them in some specific way for that query. Yeah, so do we have the right 100 to boost? So to do that is say we like know we want to get the right, we want to boost, we know this is a, from our query understanding, we know this is like a product name query. They're searching for a specific brand of something, of, sneakers, or of like, a book by name or something. Then we need to make sure when we get the top 100 embeddings that like those exact name matches are like represented. So there's kind of a chicken and egg problem here, right? It's like I want to promote those things out of the initial candidates, but to do that, I need to make sure those things I want to promote are in the initial candidates. So tricky thing to get right. And that's really a lot of hybrid search problems really sink or swim on whether or not you get the right mix of candidates in your first pass retrieval so that later re-ranking stages, knowing more about the query, can actually do something intelligent with them. So let's start to get into like our how we would think about this from a retrieval standpoint. Our 2021 or whatever vector database is like literally this. It's like select documents from search engine. We just rank by vector similarity, getting the top 100, right? We have a query embedding and like a title embedding or whatever we have, or a document embedding, and we're just getting the top 100. And what they would say is if you wanted to filter, which I would talk about, maybe you post filter and then you get some more, and you post filter, you get some more. That's all like Michigana. It's like not very exciting. 2025 vector databases have realized this is a problem. That to solve this chicken and egg problem, to get like the candidates we need, let's say a user searching a garden like search engine for trowels. Trowel is a type of shovel. Uh, to get the trowel matches to rank, to like see the trowel matches that are like exact product name matches, I have to filter down to them and then rank them by vector similarity. So I need a capability to select for those candidates, to explicitly say, I want these types of candidates in my mix. So in this case, getting a set of candidates that's like where trowel is in product name, order by vector similarity. So now, and this is something that's really important, if you have a vector database or a search engine, you should really be asking and digging into how exactly does filtering work for for my vector retrieval so that I can get a good mix of candidates up to higher layers of boosting and re-ranking. This is a huge topic, and you will see people talk about, oh, we do filters, but actually they're post filters. They're just like reducing the result set, which is less than ideal. What you really want is a good pre-filter, filtering while searching. And you want to understand, especially if you're at high scale, what are the performance characteristics of this? And I've been shit posting on Blue Sky about this, like just talking about looking at some interesting databases from Qdrant does an interesting way of building up their vector index to do filtering. Um, Pinecone has a really cool way. TurboPuffer has a really cool way, but it's not like baked into the like original like research of things like if you know like how vector databases work, the HNSW data structure or any of the other. It's not something that's usually baked into that. It's something added later that people realize they needed. So definitely make sure you go and figure out how your vector database does this. So you can do this. This is absolutely needed to do hybrid search well. And of course, when we get down to this level and you start thinking about what are all the things I would want to filter on? Well, there are some things that are like maybe mandatory filters that you're just going to have, like the right department and like that you're searching the right item type. And then there are like making sure I'm getting the right set of query terms in the mix. Okay. And so this where could really represent anything. It needs to represent any kind of tokenized text, any filters, like boring filters, old school filters, like getting in the right category department, you know, whatever you think is, whatever your data has represented fairly well. And at this stage, yeah, we're completely ranking by vector similarity. We're ignoring BM25 for now. Yeah, as I said, there's practically a top K. Now, it's kind of boring if we have vector search and I like force you to only get these candidates of like, oh, I have vector search, but now all my vector matches are always going to be keyword matches. It's like, well, what was the point of building a vector database if like you're forcing me to do that? Like what the hell? Like, but luckily, the reality is we have lots of different candidate sets that we might want to express for our later rankings. So, or this top one that I've shrunk down, we get 100 from that set that are like keyword matching candidates. And then maybe 100 from this set where we're not enforcing the keyword match constraint. We're getting 100 from a different set of results that just like in the mandatory, maybe it has to be in the department or whatever. And this is where the rubber hits the road on your design, your domain. How is your data represented? Do you have what characteristics? How are users querying? What characteristics are attributes of your documents are actually on the items themselves? Do you need to use something like an LLM to like enhance your documents and queries to get at that and then improve your filters so that you can build better hybrid search? So with lots of squiggly lines, you might have candidate set A, this is lexically filtered, and then maybe candidate set B, pure vector. Then we pull these candidates up, and then there's a boosting, re-ranking, whatever phase. Uh, yeah, and of course we don't want to just get this candidate set A because those are like pure lexical matches. There's a huge benefit to also just having vector matches, like the things that don't directly match the keywords the user search for, but have the same meaning. Yeah, and there's trade-offs here, like of course pure vector is more recall, and the lexically filtered to the keywords is going to be maybe more precise. And this is where, and you'll hear these terms brought up on search teams. If we have L0 retrieval, that's like usually our first pass. It's good to, a big pattern you'll see in information retrieval are like layers. So you start with like higher recall and you refine as you go down. And you can dial knobs at each layer to be like, oh, I'm going to like increase recall at the base. And then at the next layer, L1, I'm going to like improve precision or do re-ranking a different way and so on. So L0 retrieval, candidate set A, filter to lexical, candidate set B, pure vector. We call these, you often hear these talked about as arms. And sometimes arms are complete systems built for this. So sometimes people have like a retrieval arm that's like a set of candidates from like a cache or something, or what's historically worked well for this query, or you know, like I have here, lexical but ranked by vector, those kinds of things. And yeah, there can be many things. You can imagine like maybe we have a candidate arm that's like one term matches, maybe all terms match. We could even though I have like ordered by vectors in here, maybe we have a set of candidates that's actually a bunch of vector or lexical results. And then we maybe have just like just the category, or maybe there's like a direct phrase match. Maybe we have a set of candidates that's like based on some really deep understanding of like someone built out a really great taxonomy and managed vocabulary, like this equates to that using some kind of synonyms or something like that. So all of those are totally valid, different kinds of retrieval arms. And then later we pull this up into higher level re-ranking. But a lot of this is depending on the query. So we switch things on or off depending on the query. So we may have some queries where it's like we really want to focus it on, we know that the color is important. We really want to focus it on the color. We've parsed out a color from the query. We're going to turn on the filter for the query so that we're pulling up those candidates and bring that to subsequent stages and so on. And then finally, we have a boost maybe. Here is a pretty naive score plus equals, let's take the product name index for all the L0 matches. And if there's a garden trowel, maybe a phrase match on garden trowel, this is like made up Python pseudocode. We increase the score somehow. Um, and those get pushed to the top. Or a model. Like at this stage, we may have like cross encoder, learning to rank, all the cool stuff all the cool things people are doing these days at a bit higher. But the main thing I want you to take away from this is that the core bit of functionality that you have to really focus on when you're doing hybrid search is this filter to in vector to uh, into a vector similarity system, pulling out the top most similar vector results filter to this. And that is like at scale, that is the operation you really need to care about when you're doing this work. Uh, so that is the slides. I do have a notebook and I'll even paste it to, can I paste this to the chat? People can go nuts. Boop, boop, boop. Well, it's not letting me copy paste, but I'll do it later. So we have a hybrid search notebook. This notebook actually does two things. It has a built-in lexical index using search array, which is just a dumb thing for prototyping. Full text search that kind of feels like a NumPy array. And this is all based on some basic Python PyData stuff, and also just straight up brute force NumPy for vector matches. So NumPy is just the Python array library. And if you do like a dot product, for example, you can get the similarity of two vectors. It's that simple. And you can do things like filter down to the only the vectors that are matching the lexical matches and that kind of thing. So I'm not going to execute this because the embedding takes a while, but I just want to walk through it relatively quickly. But we're just doing a mini LM dumb way if you want to prototype. We're creating I'm using a data set called Wands, which is a Wayfair's open furniture search data set. Great. I really appreciate if anyone on the Wayfair's on the call, good on you for releasing this data set. Just loading it into a Python data frame and then concatenating it. I create an embedding this is just a NumPy array of every embedding, just with the name, kind of dash dash description. And then as a lexical index, I've built an index for description and name using Snowball Tokenizer, which if you're not familiar with lexical search, this is just a way of taking English to root forms. So if someone searches for MARY or MARYS or something like that, it all gets sort of stemmed down to the same representation. A lot of lexical search is like playing with tokenization so that terms map to a kind of equivalent space. But we get a tokenized view of the product description, a tokenized view of the name. And what we can do when we have this is we can actually we'll take a query like leather love seat, and we can get a score. In this case, we're summing, this is the name. So we get for leather, we get a BM25 score. For love seat, we get a BM25 score. And we sum them, we get a score for each document, and we really just see like whether there's a match by checking doing greater than 0. Same thing for description, same exact code. And then if we pass a list score here, by the way, is a search array function. If we pass a list of query terms, it is a phrase search. So we'll get like phrase matches direct, like if you actually search for leathers love seat, that leather love seat, the phrase pops up. And so as an example, here are the phrase matches for leather love seat in the data set. Same, this is just any mention of leather or love seat, not phrase. And if you play with this notebook, you'll see that. And then, of course, cosine similarities. So cosine similarity, this is just under the hood. There's lots of different similarities. This is a really straightforward one to implement. That's just the dot product. If the vectors are normalized, we don't do this, but it's the dot product of the two vectors. And we get the most similar. We get the ones that have the highest, the rows with the highest similarity that goes from -1 to 1. If we take our query, again, this is a leather love seat, and we get the similarity to the embeddings, and we'll get top 10. You can see here, and then this might be our L0 we talked about, where we are pulling up a pure vector search arm of results with a product name, leather square arm love seat, leather love seat. All these things are different kinds of leather love seats, which is good. Some of them directly say leather love seat, like as a phrase. Other ones are, it's kind of square arm love seat. So we get like, this is 10 vector search results, perfectly fine. But we want like filtered vector search results. So this is the step where in real life, you need to figure out how your vector at scale, like you can actually use NumPy and dumb things at, you know, relatively large, like hundreds of thousands of vectors, and it actually works pretty good. It's a brute force vector similarity. But what we're doing here is we're taking the embedding and we're saying, where are their phrase matches? Let me get down to a filtered view of the embeddings. Within this filtered view of the embeddings, we search, and we get the top 10 out of that. And this is just mapping back to the indices in the original data frame. So don't stress too much about that plumbing. But if we get the most similar where there is a phrase match, you can see here the similarity. Whoops, don't have the similarity. But the most similar ones are these guys. Obviously, these all have a phrase match. And what's interesting is some of these are actually like relatively high similarity, and other ones, because of the description or whatever, they're not necessarily as high of a similarity in our embedding. And we can get lots of arms. We can get lots of candidate arms. We got like just name matches, just description term matches, description phrase matches, name phrase matches. And this is the same plumbing code above, and just building up a set of indexes into the documents and scores. And you can see there's a lot of variety. They tend to be higher, but some things are like 0.57 cosine similarity. So whereas if we entirely relied on the vector, which is the first one, we'd only get these candidates. We can combine the arms, and you can see we got a set of documents and a set of similarity scores. And they're not sorted. So you see here, there's like 0.57. At one point, I thought there was a 0.4. We can sort them. And you can see like, this is actually the entire index. Oh, no, it's not the entire index. Oh, I think this code just didn't execute. But you can see here, we got our top results. And then we might, okay, so that's gets us however many, like, what is this, 40 or so results. And I should add, when there is something from 2 arms, we just take the maximum, which of course the similarity here is the same, so it doesn't matter. So let's think about our L1 part of our ranking. So L1, we're gonna get the BM25 score from the name index of doing a phrase search. This is exactly the same code before, except we're not doing greater than zero. We're just literally giving a list of query terms to search array score function, gives us an array of BM25 scores, which are mostly zero. Some of these are not. We see what are matches to this phrase and that are matches in the original, and we end up adding them right here. We add the phrase score. And of course, this is an interesting point because adding a BM25 score to a cosine similarity, these are like completely different on completely different scales. So that requires a bit of tuning. And finally, you can see, oh, we've pulled up a bunch of candidates of different kinds of leather love seats based on different lexical criteria. And we've also said, oh, well, let's make sure if there's anything that directly matches the name leather love seat, we pull this to the top. And if we were really smart, what we would do is have an LLM in the loop to say like leather love seat. Do I want to pull out like an item type like love seat? Do I want to pull out a material like leather? Do I want to like explicitly have certain types of like filters and things I'm pulling out of that user's query? And similarly, we would do the same on the documents themselves. Be like, how could I extract, like maybe there is no material in this, but if I look at this document, could I extract a material and actually add a material field for this document so that these filters, which were so far just done on description and name matches, could be done on other things that are relevant to the query, like the like material or color or anything else that matters to the user. So, so with that, we're just about at time. Um, I don't know if people want to.
Yeah, can I ask you a question?
Yeah, go for it.
Yeah, so how do you think about like the relationship between, like pre-filtering, hybrid search, post-filtering, how you decide, what mix to do, how to do it? What's like some general guideline?
Yeah. Yeah, post filtering is always like a safety net. So if you're like removing things from results, you want to not remove a lot of them. So it's like, oh, I need to remove something that's uh it's hard for whatever reason to remove from like ideally you would have removed it from the first set, but for whatever reason it's not possible. So you've pushed through a lot of results, you're pulling things up, and maybe there is some thing that occurs 5% of the time and you want to eliminate that. Uh, maybe it's like maybe an example would be like the rare case in a social media or not rare, maybe it's not rare, but like the case in a social media site where something's like offensive or whatever. You're like, I don't want to like think about this in my core retrieval all the time and like build out these expensive filters because if I do it earlier, it's going to be more expensive. And the earlier stuff is like stuff that's just like, I guess like in some ways hotter or like very uh always going to be like active because you're going to spend CPU on that every time. And it's going to, if you didn't have it there and you did it later, you would end up like getting a bunch of results and then like completely removing them. You'd have like start with 100 and get down to like five after you filtered it out. And that's something you want to avoid.
And what about like pre-filtering, that versus hybrid search, when it comes to like how do you trade those off?
Yeah, I always think about I always think about hybrid search as like the pre-filtering is a thing that enables the hybrid search. Uh, but sometimes it just has to do with whether or not you want to think about sometimes things come out and it's like, do we want to filter or do we want to boost this? That's another thing. It's like, is there an attribute that I want to enforce as a hard filter to make sure it's either in the results or not in the results? Or do I want to take that and based on the query or situation or the type of attribute it is, do I just want to promote that higher? Um, an example of that is like if if for some reason like you wanted I don't know, you're searching for something and you're searching for like, if you're searching for a book by an author, you definitely probably want to filter on that. If you're searching for a book, but maybe it's in a genre or something that could be fuzzier, maybe you start to like that's become starts to become a ranking criteria. But you also want to make sure it's a filter. You want to make sure one of those arms, you want to make sure it's specifically selected for as like one of your candidate sets that like I'm making sure like I have a mixture of science fiction and stuff because I explicitly queried for that, if that makes sense.
Um, a lot of people are wondering, and it might be a good time for you to talk about this. Like, what are you going to discuss? What are you going to discuss in your course? Like, you're doing a course that like dive deep into search. Yeah, what do you?
Yeah. So getting deep, definitely getting deeper into this stuff, more hands-on with this stuff. And then also the actual process of query understanding with LLMs with a real data set, like what sorts of attributes should we be pulling out? And then what kinds of way, how are we laddering up the representation of documents themselves to those? It's like dimensions of intent, I like to call it. So are you, how are people searching? And some of that's not necessarily expressed through the query, some of it's like user based. And even in things that you think are like completely pure, like knowledge-based information retrieval, there are like subdivisions of use cases out there. So at Reddit, for example, is something like a trending news topic or something like, is this a product name that you want to get reviews on? Uh, is this like some cool like meme thing? And if you break out those things, and within each of those, how you search them would be completely different. And now we have LLMs that really help us with this class, both the query sort of routing problem and the query understanding. So within the news article, maybe there's like, what are the specific people being talked about? What are the specific types of like entities or businesses being talked about? Or within, if we're detecting a product review case, what is the product name? What subreddits do we know are like associated with that? And there is a tremendous untapped potential there because I feel like in the past, for traditional search teams, there's almost like a feeling in the gut of like, oh, that sounds like it's going to be hard. But I think what I'm trying to sort of go over, maybe discover with the attendees is like, how hard is that anymore? It seems like we should be able to do that. And where's the boundaries of what's possible with LLMs in real time, like processing live search queries? So,
Very cool. Yeah, I look forward to it. I signed up last
oh,
night.
good. I
Very
appreciate
cool.
that.
Yeah.
So you
Um,
heard that here. Hamel says
one,
sign up for Doug's course.
yeah, definitely. I recommend people doing that. One question that came up that got some upvotes is when you were discussing in the notebook about combining the BM25 and the cosine similarity, you mentioned something about tuning it. Were you like scaling the BM25 to be on the same scale as the cosine similarity, or were you doing something else? Can you talk about it real quick?
I wasn't doing anything in that notebook. I was just adding BM25. Um, there's a strategy that I talk about in relevant search that comes up when you're doing a manual ranking function called tiering. And what that is like you have for your first pass, you kind of have a set of scores that are like in a range, like, I don't know, -1 to 1. And then maybe when if you want to boost on something like BM25, and it works out well in this case, but you kind of want to like have like a stepwise, these get like 10x the score or something like that. So it's almost like, yeah, they're cosine similarity plus BM25, and it does turn out that BM25 is like 10x cosine similarity just by happenstance. And then everything else is like at that cosine similarity layer. Uh, but yeah, I didn't, when you do this kind of work, that's always like the art and science is like playing with these magic numbers to find the right thing. And when it gets so complicated, that's really where it becomes, you want it to be like a machine learning problem. But that's its own set of trade-offs.
Makes sense. So in the simple case, maybe you just do some tuning, like some hyperparameter search in a way, like against the data set.
Yeah, yeah. That hyperparameter search is underrated. Like a lot of at Shopify, we got by for a long time with just doing Bayesian optimization of our hyperparameters of this thing. I just like you can imagine in our case it was a Elasticsearch query that followed a similar in spirit practice, and it was like, how much should we boost this? How many candidates should we pull back? But these like we kind of like generally have a sense of how what works well, but to like at the end we would say, okay, well let's put on our hyperparameter optimization and sort of like what are good parameters of this ranking function we feel like we've done a decent job crafting and understand.
Makes sense. Um, okay, I can pull some questions from the chat. Um, some other
Yeah,
ones.
sure.
Marx asks, if you don't have a golden data set, how do you evaluate your candidate selection strategy?
Ah, yeah. Well, hopefully you get one. I have a whole thing that's on NDCG is overrated. If you go to my blog, you can go look at that, but it's all about alternates to ND like traditional evaluation. There's someone posted LLM as a judge is a whole thing, and that's also something we'll talk about in my course is using LLMs to evaluate search results. Um, the tricky thing I find the best way to do LLM as a judge is to at least get some basic golden set down because you want to be you don't want to like blindly trust the LLM as a judge. You kind of like a lot of times you start out like 80% there, which is useful, but then like that last trying to get to that like 90-95% where you can really trust it is a whole other level. Um, but like without that, I feel like here is a flow that works and has worked in the last couple of teams I've been on, regardless of golden set. A lot of times there's a golden set. But what I will sit before we're about to launch something, we will have some kind of at Shopify, we call it a sense check. At some places, it's just a bug bash. But literally at Reddit, we called it a Pepsi Coke challenge. But we literally just like got side by sides of here's my thing I want to do, here's the old thing. And it's tricky because like to do this really well, that's why I call it Pepsi Coke challenge because it's like when they do Pepsi Coke challenge, they don't tell you which is Pepsi and which is Coke. If you sit on a bug bash and you're like, this is the new thing, go team, we want to release it, everyone likes the new thing. Um, but you literally get side by sides of like dozens of queries. So if you have your new approach and you know the population of queries that have changed, so let's say you have thousands of queries in some set, you don't even have to have labels for them, but you know out of those thousands, these couple hundred have changed. Let me sample out of those couple hundred that have had significant change and socialize them around to the team and just get people's gut check on them. Now, there's a lot of flaws with this. There's like gut checking from your teammates if you're like they have nothing to do with your user population. Um, but and like for trade-offs and like signal to noise ratio of like sometimes getting a really good golden set is kind of like people really invest heavily in it, and it may not be worth it at whatever stage you're at in your progression as a search product.
I love it. Like looking at data comes up again.
Yeah, exactly. You really have to look at it. You can't just be like, oh, my NDCG went up 0.01. You really have to be like, what changed? And the other thing I'll say is when you have a golden set and you most people see the average change in their metric, they don't look at the tails. So like they don't think about the thing the use case they completely obliterated and destroyed versus the thing that got better. And if there's like tremendous variance in that, that is way riskier because your golden set's often rarely super, unless you're Google or something, not like representative of everything. It's way riskier than like the thing that really worked well and targeted the five queries that represent your problem and didn't change anything else, but NDCG like barely moved. Like that's, I'd rather have the five queries change and NDCG barely move than like have a big NDCG change and like huge variance in like every query without like doing tons of checking and like having lots of checks and balances.
Makes sense. Actually, I really want to ask you, so this is the last question. Um,
Mhm.
so I think the number of people doing retrieval has like 10x in the last 2 years because of LLMs. But
Mhm.
like, retrieval has been around for like, a while, and you have been working in retrieval for a while. What are like the biggest mistakes you think people are making with RAG in the retrieval they're doing for RAG, that you've noticed or that drive you crazy?
Um, well, RAG has a couple of things that are help you get away with stuff that you wouldn't necessarily get away with in a traditional search. So traditional search, you issue a search and you want results back in like tens, 100 milliseconds or something. Of course, like with an LLM, you're like are chatting with a chatbot and you're seeing the words scroll on the screen. So you get away with a lot of stuff. I think a lot of what people uh, do is, well, first I'll say there are a million things that can work. Like people that are like, you can manually create a ranking function. You can build a model. And a lot of it depends more on your team's competencies. One mistake is like maybe caring like too much about like, especially most people have like are dealing with millions of documents. And at like some scale, billions of documents, it starts to matter. But at most people's scale, to say something controversial, like I'm not sure it matters what vector database search engine you're using, as long as it can do like pre-filtering and like basic search and these kinds of things. The other thing is like to that point, a lot of people got into the like I put that slide of like vector database 2021 versus now. It's like over time, people for almost every vector database has gradually evolved into a search engine. And that's the one area I might be like, if you're thinking about this stuff, like make sure that your vector database is far enough along that curve that it can do keyword search. It can filter reasonably pre-filter at a reasonable speed. And it has the bells and whistles that you sort of take for granted in like a search engine or really a relational database. Uh, uh, that you want to make sure that your thing has it. And I think a lot of them are much better and farther along. But yeah, I'd say like people get like too cute about like the like, oh, what vector database are we going to choose or like all this stuff. And I'd say that a lot of things can potentially work.
One thing I'm really happy about is we got through this whole talk on RAG and we didn't ask you what your favorite vector database is. And so
Oh
I'm
yeah.
not planning on asking you that. So,
I
I mean,
I always say like go with whatever your team is like comfortable with. Like that to me is the most important thing. Like at Daydream, we have a team that's like very comfortable with Elasticsearch. And so that we went with that. But like other places are comfortable with other things, or like maybe got started in a direction they really know that technology and have a good relationship there. It's like are some people love post PG PG vector. It's like there are a million ways to skin a cat, right?
sounds good. Okay, so we'll email everyone the link to this recording. Sometimes it takes 48 hours. And also a link to Doug's course and other information that he went over, even the Colab notebook. And yeah,
Definitely.
thank you for coming and look forward to it.
Yeah, for
Look forward
sure.
to your course, Doug. Thanks.
Yeah, thanks. Thanks everyone.